completely different.
Lift all this off.
That's what I was saying, not really a big problem.
Now I see the difference.
So here you can see the pretty changes straight away, yeah?
Yeah.
More easy everything.
Yeah.
Less things inside as well, no?
Should be more or less the same, no?
Right.
Still, add the small plate, get
No, it's
bigger.
probably-
Hot water plate at the front, heating circuit plate at the back. Normally the heating circuit plate is much smaller on this one. This one is slightly easier to see the ident label. You can see the identity label I was talking about there.
Yeah.
And this one tells me, this again is a Series 7, but it's a Series 7 DS, but not the reduced. They do a further version that's a reduced depth as well on there. But this is Danfoss's name is a VVXi FI fully insulated 1/2. So it's a size 1 hot water plate, size 2 heating plate. You might have a 2/2 or a 3/2, depending on the size of the apartment. And there's a UK number there and an L number as well on those. As I said, if you ever need to phone us for spares or you need something to know something about the unit, if you quote those numbers, we can pull the build sheets up for those particular units and tell you what units are in, what's in there, what size valves they should be, what type of plates they should be, and things like that. It does occasionally happen the wrong units get put in the wrong apartments. Been there, done that one. So it does happen, unfortunately. Most things on this one are pretty much the same, except it's the hot water temperature control valve is completely different on this one.
All right.
So on this one you've got your primary flow and returns, and you can see the indication marks, the embossed labels there. They're a bit easier to see on this one than the other one. But you can see the primary flow is this side, primary return. Heating can be at the top or the bottom. Again, we've got it on the bottom on this one. Cold water out, hot water out, sorry, cold water in. On this one, again, exactly the same things to apply, don't backflush through it.
Yep.
It's even more important on this one actually not to backflush through it because of the way the hot water temperature control valve works. Primary flow comes in, there's my dirt strainer again. I use a little Tupperware bucket to drain those out on there. And it tees off either into the hot water plate or it tees off at the back into the heating circuit plate. Again, there is an air vent. Don't forget that's on the primary side, so be careful of that one. I kind of wish they wouldn't put it there, but they do it as a default on that. We do get asked occasionally, why don't we fit automatic air vents to them? There is a good reason, because all the Danfoss's ones leak after about 6 months, and I think it's the same you see everywhere where there's an automatic air vent. After about 6 months, they all leak and they all look pretty rotten. Also, we can't always make them fit everywhere.
You have to put isolation valve before.
Yeah, and they're a pain. And then if they fail, you can get some of them sucking air in as well.
Yeah.
So we do get asked, but we don't fit them. The other thing we do get asked is why don't we fit a pressure switch, flow switch. Some of our units we can, it's an optional extra, and the beam counters I was talking about, will cut that out. They'll take that out, so you can save 50 quid there, and they do, unfortunately. So it tees off either into the hot water plate or into the heating plate. Hot water goes through the plate, out, back through the hot water temperature controller, which again isn't set, through there, through the energy meter and back onto the primary. Heating circuit does exactly the same, comes through, back through the 2-port valve again on the heating circuit, which is the same as the one we had next door, through the RAV-K, which again is exactly the same valve, same AVPL, comes back round and through the energy meter and back out again. So the meter doesn't know the difference between the two, it's just energy, energy. Difference on this one, if you look at the boosted cold coming in, one, there's a spacer piece here, that's for the prepaid credit metering valve to go in if you ever want to retrofit it. People, on a lot of our older ones, we used to fit the prepaid valve on the primary return. We've stopped doing that because the way it's wired now is the prepaid valve goes in on the boosted cold, so it stops them producing any cold water and it's wired so the heating circuit can't come on. But if they haven't paid a bill and they've been cut off, it still keeps the primary flow going through. So you don't have your pumps pumping against dead heads and things like that, which can affect things. And it also keeps the chemicals in the primary system going through, so that's why we do it that way now. The next thing you'll see, there's a shock absorber pressure arrestor. So that's when you turn your taps on, you don't get that bang of water sometimes on there. That's missing on the unit next door because you've got hot water recirc. You take that out and you put that's where the pressure relief valve goes instead. So if this had hot water recirc, that's missing on there. There is a little check valve in there. There's a single check valve in there as well. One other one on this one, you've got your primary flow dirt strainer. Your heating circuit dirt strainer will be down there somewhere, hopefully. There should be a heating circuit dirt strainer.
There is, yeah.
There is a third dirt strainer on this particular unit.
They're down there.
Yeah. Just here, you see there's a little blue tag just under here,
Yeah.
where my finger is. There's a top hat dirt strainer in there. That's because even though that's your boosted cold water coming in and it's actually your drinking water, you think it's clean. However, when you've been doing all your pipe work, soldering whatever in bits and pieces, and there's bits of flux and Boss White or God knows what else in there, earplugs occasionally, where people have been pissed off on site, I've seen that. They put things down pipes.
Yeah.
It comes up, we don't want anything going through this valve or that side of the other side of the plate, so we're protecting both sides of this plate. So we've had it on that dirt strain, the only time you need to check it, we've had it where they turn the cold water on, they get a flow of cold water. Turn it to the hot side, and only a dribble comes out.
It's probably not.
They all go, oh, the plate must be blocked. Not necessarily. Check that dirt strainer. Because it could be that dirt strainer's blocked with flux and other bits and pieces. It's just a little top hat. It's got a built-in rubber washer into it. We carry them as spares because they do get lost. But people forget that that's there. There's a dirt strainer in there. So we've had it where that's been blocked, and it's that that's caused the flow issue, not the actual plate being blocked. So just be aware of that one. On this particular control valve, it has that extra dirt strainer in there. So that unit's got 2. This unit has 3. And then that's what that little blue tag is denoting there. Again, pump's exactly the same, and the settings on the pump for your heating circuit are exactly the same, so I won't cover the bits and pieces on that one. Expansion vessel again, I've never needed to repressurise one. No, that's a lie actually, I'll tell you why in a minute. They're pre-pressurised. I've never needed to actually repressurise them above what they're set to, which is on the bar. The reason I say it was a lie is because we had a site a couple of weeks ago where the bloke said, I've depressurised the unit, but I've still got water in the heating circuit. What's happened? It took me ages to work out what he'd done, so I got him to send a picture. What he'd actually done was opened that
Alright.
and depressurised the balloon, not the heating circuit. And then couldn't understand why there was still water coming out when he was trying to undo that union. He was getting slightly wet because it's still under pressure, so it depressurised the balloon and nothing else. I've not seen that one done before, but it does happen. Things do happen on there. There's your pressure gauge. When you're moving this around like I can, make sure they don't kink this pressure pipe. Because if it's kinked, it won't record the pressure properly. And I've had a couple where they've actually forced it all back up, and it looks like it's showing 1.5 bar. Then they say, oh, well, the PRV's leaking.
That's probably more
And
than
because it's above 1.5 bar, but it can't register, so it's not registering anything. So just be aware of that. It's something we're looking at changing. We're trying to look at something different on there, on that one. Right, hot water one on this one. That one next door is an AVBT. This one is what they call the IHPT. This was done specifically for the Swedish market. On the one next door, if you turn it to 0, you'll get cold water. It closes the flow off completely. This one never completely closes. If you set it to minimum, you'll still get about 38 degrees hot water. It doesn't completely close. Again, if that capillary tube is damaged or cut, it will fail to fully open. It doesn't fail to close on there. These again don't come set when we set them. When we deliver them to you, they're not set. Now, this one, there's no actual set, even though there's a scale on the side. The way I set them, and I don't know where this one's set to at the moment, it's set to about 2.5, okay. The way I set them, and I'll do this one because I know where it is.
Maximum back.
Yeah, turn it all the way to minimum. You remember the training. all the way to its minimum setting, which is fully anti-clockwise until it stops. Look where the little nipple is, that's a security nipple, so you can put a security seal or something on it to stop people tampering. Very rarely done though. And then that's where it stops, so we'll say that's 3 o'clock. And then turn it about a quarter of a turn until you just start to feel it tighten up. That's your start point. And then from there it's 1, and you want 55 degrees, so it's 1 3/4 turns, which is roughly where it was. So whoever's done it has done it properly. It's not necessarily exactly right, but that gives you a good start position for setting this valve. This valve's not quite as simple to set as the other one, but that gives you a good start position. Don't do what one company did. They had one bloke here, one bloke at the tap. It's gone up a bit, it's gone down a bit, it's gone up a bit. Day and a half they were there on one floor.
And they couldn't commission it.
Couldn't commission it until they phoned
So
us.
how do you know how much to turn, like, to get that temperature there?
Because I'm used to doing it.
Experience.
Or is there a guide
Pretty
from,
much,
is
you
there a
know.
guide from
Experience.
Sam's where it tells you, like?
No, you could use, there's a rough guide on there. The way Danfoss do it, they start from it fully open and wind it back.
Okay.
My quicker way of doing it is I start from minimum and go forward slightly. It's easier and I find it more accurate.
Okay.
This valve works in slightly different way to the other one as well. So where I've set it is approximately 55 degrees. So what you do now, go to your tap, run my tap,
Display.
60 seconds, have I got my temperature? If I need to tweak it up, then I turn it up by a quarter of a turn at a time. Then you have to wait about, the valve will respond instantly, but you've got to kill the leg of water between here and there because you haven't got any hot water recirc on this one. So it takes about 20 seconds till you get the increase within reason. If you need to turn it down, wait longer because you've got to kill the energy that's in that plate and the energy that's left in the pipework. So it can take up to 60 seconds before you see it drop in temperature by a significant amount. So just be aware of that one. But where I've set that is pretty near to 55 degrees.
What about if you don't reach the kilowatts, which is,
If you're producing the temperature, don't worry about the kilowatts.
yeah?
Yeah, because it's the temperature you want. Don't worry about
Yeah.
because the way the valve works, it will vary. So your kilowatts will vary because the valve will be modulating to control the temperature. So your kilowatts will vary. You can put a figure down, but that's the only thing I meant to mention. That it's rare to put an actual kilowatt figure. You can put a kilowatt figure down, but it will vary.
Yeah.
And if you have more kilowatts than design,
There's not much you can do about it.
That's what.
so you can't
Yeah,
play
but
with,
you can't play
you can't
with
play
that.
with
No,
this.
the
because you
temperature
need
will
it-
go
yeah,
down.
Yeah, because it's temperature control.
So
The-
you
these
need-
there's this one as well as that one are temperature and pressure compensated.
So are you
If
ever
it's
gonna,
like,
are you ever going to be able to achieve the kilowattage required for, like, say, domestic side and the temperature?
You'll
You're gonna
find
That's to do
it
with
will
pipe
ve-
sizing,
Because
They're
at the
gonna
moment
be
they're
slightly
recording the
out. Yeah.
kilowattage,
The kilowatt load.
and they're putting it down exactly to what's required, and then we're getting the temperatures required as well. So you're not going to.
It's dependent on lots of variables. Sometimes it will be right, sometimes it will be wrong.
Okay.
it's to do with the pipe sizing as
Yeah,
well. If the
yeah.
kilowatts are higher
Yeah.
and you
Yeah.
get the temperature right,
Yeah.
so that it's so precise.
On this one, there's also, where this one still has that trickle bypass, but this one has an energy saving. That one, and it's a bit awkward to work out on that one because you've got the hot water recirc. Let's take it, we'll describe that one without hot water recirc. That one, if I set it to 50 degrees, and because that's my default, if we didn't have hot water recirc, we've set it for 50 degrees, and my primary's at 70, and I know that's what we're coming in. If that unit's not been used for an hour and no heating, I'd expect to see my primary flow temp coming in about 55 degrees, because it's about 5 degrees above my set point, because it's trying to maintain. And every so often that valve will open to let a little more primary flow through to top the plate back up. This one has an 8-degree setback. It's an energy saving of 8 degrees. So once this sensor, you can see the sensor there, there it is there, sorry there. Once that sensor is there, in that plate, it senses the hot water. Once that senses that it's at my design temperature, it will start to close and it will set itself back by approximately 8 degrees. But the second you open your tap, it it's producing at your hot water temperature again. But what it's trying to do is an energy saving thing on there. So if we said this one 55 degrees, nothing's been used for an hour, no heating's come on, and the plate's it's just in standby, I would expect to see the primary flow temperature about 8 degrees below my desired hot water temperature. But again, once I open my tap, it will be producing at your instant temperature. So we can have a look and see how well it is before.
Keith, also regarding the flow rates, you can't control anything in there about.
No,
flow
the unit
rates.
will react. It's your pumps downstairs that will
So it's all
ramp
just
up and
from
down.
the-
So the more pumps you turn, the more taps you turn on, the more your pumps
Yeah.
should ramp up
So all
to take that into account. Unlike a combi boiler, and my wife does it deliberately, if I'm in the shower, she'll turn the tap on. She'll run the kitchen. Oh, I forgot you was in the bath. What happens? It goes cold. Doesn't happen with these. One, because the plates are bigger, but also your pumps should react instantly. The second they sense that there's a drop in pressure, your pumps will react and increase the flow rate through the unit. So this unit again should be capable of running 3 taps at the same time, as long as it's within the design flow rates of it on there. So it will vary.
Yeah, so at the moment we're playing around with the tenants out there just for the flow
Well, that
rates.
one.
Yeah.
Yeah, we want to see, again, normally most apartments have about 1.5 bar coming in, occasionally 2 bar, but you want to be able to run 3 taps at the same time without any water coming to a dribble, which does happen if they've not set the flow enough. But we want to see a minimum of a bar on this
And
particular
what's the
unit.
max? Like normally we're going what 2
Three.
to 3. We
That's fine. We can
2.5
take
to 3 max.
these are PN16 units, so we can take quite a bit of pressure on here. We haven't got a problem there, but we don't recommend it because you don't need that much kind of flow rate. Because you've got lower flow rates at your taps. You don't need 3 and 4 bar.
Yeah, yeah. Do you remember in the beginning we had to do
Yeah, that's
reduce
what I'm
that
saying.
down,
Most of
down
them
because
are
in
set
3
to about
bar
2 to 3 bars.
with
Yeah.
a flow restrictor, it was giving a massive, about 11, 12 liters
Yeah,
on the
yeah.
kitchen.
Yeah, you don't need, because you've got everything's being reduced, you don't need those massive
Yeah.
pressure. We just want to see, make sure you've got more than a bar pressure, because that's how the valve will operate on there, on that one. So if I just take that off, go to loop 2.
You turn the kitchen on.
So you can see
Yeah.
we've got a slight
Water.
trickle going through there at the moment. 30 watts.
Mhm.
We just turned it on.
Top.
Yeah, it's going now.
It's fine.
So we just jumped up to 665 litres now on there. So that valve's now valve's controlling. It's quite a high flow rate actually through there, but you can see the valve, it's gradually slowing down. You can see how the valve's
Yeah.
controlling on there. But in trickle, every so often I would expect to see just a couple of litres go through there as well. Where I said that's about 28 litres an hour, sorry, would trickle through there to keep warm. This is 6 to 10, but there is lots of variables involved in that. My primary flow in return, my primary flow temp, my cold water temp, what I've actually got this valve set to. So the higher you have it set, the more it has to, and longer it has to remain open to keep the plate primed at those higher temperatures. So at the moment we've got 339 litres an hour going through there. I've got 66 coming in, 28 return, and it will drop slightly. The reason you've got a higher return
That's a
temp,
high.
the reason you've got a high return temp at 28 degrees is because you've got a massive flow going through there. You've got a high flow rate. So the higher flow rate, the plate isn't having to work as hard, so it's not extracting as much out on there.
It's going quickly through it.
It's going quicker through it, so it's not having to extract as much energy. So you're therefore sending a slightly higher return temperature back. It's dropping slightly, 27 degrees is not too bad.
What would be ideal, like?
You really want it about 20 and 25 degrees.
Yeah.
And you can see on there, hang on, sorry. We're producing 15 kilowatts at the moment, but you can see the kilowatts is varying. So if you slow that tap down slightly, it will, don't turn it off, but just slow it down slightly.
Turn it off?
Just,
Slow,
no, no,
just
just slightly, just
No,
a little
just
bit.
slightly
Little bit.
down.
quarter or half or something.
see the valve,
It's
the
going on.
valves reacting
something on,
instantly
yeah.
to what's going on.
Ah.
So you might have your temperature be not over your kilowatts. You might want to put a little marker on it to say, you know, that the kilowatts wasn't expected, but you're reaching the temperature.
Normally
as long as
this
it reaches
happens-
as long as it
What you
reaches the
need.
temperature, that's the one you're interested in. Because
Normally
when
this
it doesn't
happens in
reach
a-
temperature is when people will
Yeah.
complain. The apartment owner won't care how many kilowatts it's producing, they want to know.
Yeah, that's
they're
more
getting-
for design,
Yeah, that's
in
more
order
for
to make sure
design,
the
yeah.
performance.
That's it.
This is what I'm saying. Do you know
It's
when
happening
they're doing
most
the
in
domestics?
one beds.
You know when they're doing the domestics? That's what I was trying to say. JDEV is setting these temperatures up, right? On the domestic side.
Yeah.
But then Sorin is saying they're going around again to make sure the kilowattage is
But they will check again the heat,
They'll
the
check
measuring
Yeah, the
with
kilowatt
temperatures.
it will
and all that
vary. The
stuff.
kilowatt load will vary as the valves controlling as well.
Anyway, as a third point, he's checking the temperatures again, so.
Yeah.
at
So
the
you
end
can
of the
see
day,
now
No,
my
no, that's
flow
what the
rate.
temperatures are achieved.
Yeah.
So I'm saying, is there a point of actually
checking the kilowatts.
kilowattage? Yeah.
We just
If
do
you
it in our
want-
commissioning sheet. We just put it down so you can see that it's working within you know, that it's working efficiently. If you was not achieving temperature and then you had like 10 kilowatts, you know there's something going on there. You can see now where we reduced that flow slightly, we're only running with only at 246 litres, 66.9. My return temperature has dropped slightly because I've got a slower flow rate on the primary side, so it's extracting slightly more energy out of it. So I'm returning, if I look at the energy I'm producing, 12.6. But again, you
It's
can
a
see
bit
that
high
it's varying.
compared to the
Yeah,
what we
it's-
need
it's
in here.
varying. So you can turn the tap off a minute for me. The thing with these valves and that one, the minute you turn the tap off, that valve is shut faster than the energy meter can respond to it. There's no overrun. That's why Danfoss will not do electronic control of hot water. Because there isn't an electronic valve that can open and close instantly. Even stepper motors can't do it.
Yeah.
On there, they can't do it either. So that's why Danfoss won't do it. And you can see now, I've got no kilowatts because the plate's now up to temperature. There's no demand for anything. No litres per hour. That valve is shut. The plate's saying I'm satisfied now. My primary flow temp is 67, and you'll see once the insulation's on, Fairheat, the company I was using as a demonstration, you can see it starts to drop. If you put all this insulation back on, it, of course, it's going to hold the heat back in there. So it takes longer to drop. But after an hour, I would expect to see that primary flow temp about 8 degrees below my 55 degrees.
Below.
And the return slightly lower than that. So we're saving energy. Therefore, how many buildings like this have you been in before and the corridors are just full up with heat? Because they're either running too hot or the valves aren't set properly. And I bet the ones with the Evanox units, I bet that's boiling hot in those corridors at times. Yeah? Yeah.
Nice in the winter.
Yeah. But you can see that temperature starting to drop, so I know that valve is starting to control. But every so often, once that sensor there senses that the plate's dropped by a degree, it will open up a little bit and let a little bit more flow through there. But of course, that flow is recorded on here. If it's over a certain point, it will produces energy as well, which the apartment owner ends up paying for, and they forget about that one. So the higher that's set, the longer it has to remain open
So
to
the
keep the
longer-
plate primed at your design temperature. But this one has that 8 degree setback, so it should be about 8 degrees below your design temp, your hot water temperature, after about an hour. So it's a good way to double check that no one's messed around with valves. But setting the valves the way I set them, that's pretty accurate on there. Yeah? Again, as I said, this one, if this capillary tube is damaged, you won't get any control of hot water. If they back flushed on this unit, and it does happen, even though you tell people not to, it does accidentally, people forget. The easiest way to check, if you get a spanner undoing this locking collar, pop the head off, you won't get wet, and there's a pin behind there. If the pin won't move, you know it's been blocked, because the trickle bypass is just on this valve, just under here, and you know it's blocked. And then normally phone us either to come and clean it, or we'll tell you how to take it apart and clean it. But you have to be careful. If you get a spring and a bellows pop out at you. on there, so just be aware of that one. As I say, it won't ever go to completely cold unless you've got no primary temperature coming in at all. Because of the way the Swedish market operated, that's what it was done for. They didn't want a valve that would go completely cold. One, because in the winter, of course, they get really cold temperatures. And if people do mess around, they don't want it shutting off and freezing their pipes. So that's why it was done. So it never goes completely cold. Where the other one, if you set that to 0, won't get anything. You set this one to 0, it's about 35 to 38 degrees minimum temperature. Where I've set that to about 1 3/4 turns, because of the way this valve operates, some nearer the riser might not need 1 3/4 turns. They might only be 1 turn, they might be less than that, it might be half a turn. That's not wrong, it's just the way this valve operates. But the way I've said to set it is a good starting point instead of starting from anywhere, trying to work out where it's set. If you use that as a starting point and then tweak it from there. But it could be one right next to the riser is shut virtually all the way down. It's not wrong, it's just the way this valve operates. But one further down might need to be tweaked open slightly longer than that. But again, if it's set incorrectly, you'll normally hear a big flow rate going through there as well. If I take the head off.
And once
you'll
that
hear
is
it.
set, does that have a tolerance as well or no?
So again, it's plus or minus 2 degrees on there. It's about plus or minus 2 degrees. But the longer you run it, if we run that hot tap for a couple of minutes, you'll find that temperature stabilises quite a bit. And it's then within about half a degree. It's pretty good. It's pretty good on there. There's no electronic valve that can do that. And that's why it's done. The only time we'll do electronic control on HMUs is for the really big units, where we have to because of the way the valves work. They're normally feeding multiple apartments then on there. So that's the major difference between this unit, is just these 2 temperature control valves at the hot water. On there, it's slightly different setting procedure. That one, you know, if you set that to position 3.5, 3 to 3.5,
You know already what the battery is.
you're 50 to 55 degrees straight away. This one, there's a little bit more setting up involved in it on there, but everything else is exactly the same. Doing the heating is exactly the same on there as well. You can do hot water recirc on this unit, and it goes directly in there. Where my finger is, there's a little
Where
Allen
the-
bowl in there. You can put that pipe back in. You get rid of that, the pressure absorber. That becomes your blow off, and your hot water recirc goes back into that valve, and that valve then controls. It will still try and do the 8 degree setback. But again, hot water recirc isn't recommended. But because of the size of the apartment you've got there, that's why they've gone for that unit in there and not this one. Even though this one could probably cope with that. It's just the consultant erring on the side of caution on there. We quite often find they're oversized
Yeah.
for apartments. Heating's worse than hot water, because people, you know, they realise just how much energy these new apartments don't need anymore. I say that one's only about 5 kilowatts. This is a slightly smaller apartment. It's only about 3 kilowatt load. If you imagine this is an old block of flats, you're probably doubling or tripling that kilowatt load on there. So that's the major difference, is that hot water temperature controller. Everything on there on this unit is stainless steel or brass, or stainless steel and copper. There's no aluminium in these plates or anything like that. Sorry, let me turn my phone. Only one of our other engineers.
So that would pretty much be the hot water one.
So what's that again? That valve?
This one,
Yeah.
that's
That's
the
for the-
AVPL.
Okay.
That one, it doesn't affect anything you do with hot water. It only affects the heating, and it increases or decreases the flow through the heating circuit primary side. So you're only giving it.
That's when you do the balancing of
Yeah.
those.
Yeah, you can
You-
adjust that to give
yeah,
you
to give
the
the-
heat load coming into the apartment. It's also controlling the valve authority over these 2
Yeah.
valves as well. So because it's on the primary side, so making sure these 2 valves control properly. That's also why we don't need any double reg valves, to balance the system out. We don't want to see you balancing the system anyway. It does happen again. We don't want to see you balancing the system. The units want to see full system pressure, and it's your pumps that will ramp up and down.
Oh, so that goes straight from the primary straight in.
Yeah. Your pumps will ramp up and down to take into account that demand, and these valves will operate. The more you demand on them, the more that valve will open to put the heating, hot water out on there. So that's the major difference between these two units. Again, on that one, you can see where we've moved the vent to the side. Now, it used to be directly to Orchard, and you copped a
I've
face
got that
from the
few
bottom.
times in the beginning here,
Yeah.
from the
I've been
vents.
there, done that, we'll forget on that. But it's again the same procedure, always open the primary flow on this one before the primary return. And just remember that you've got 3 dirt strainers on this, not 2. On there. The other thing, one thing that we do get occasionally is we get leaks on these pipes. Normally on where the bend is. That's because it's stainless steel where they've been doing soldering. And stainless, that's the one weakness of stainless steel, it doesn't like flux. Where they've used too much flux or leaded solder, which can still be brought. And it's where they do the soldering with these valves open. So they use too much flux and it all flows down inside
Flows
the
down.
pipe, comes down, hits the first bend, and it actually sits there and burns a hole in the pipe. Because we've got sites where they say, no, it can't happen. And we send them away to Sheffield Labs testing, and it always comes
Sorry.
back with flux and ammonia and other bits and pieces in there, or leaded solder. It's the one weakness of
It's
stainless
very
steel.
sensitive stainless steel.
Stainless steel is very
That's-
sensitive.
that's
to
why-
that. Yeah,
Yeah, very sensitive.
yeah, they say, oh, it's where it's too thin on the bend. It's not. It's the flux and stuff that has caused the problems. So if you do get a pinhole, always look for that. You'll see where it is. You'll see there's an actual burn mark where the flux
What's
is
that,
burned
mil,
through.
2 mil thickness?
It's not even that.
Not even that,
Not
yeah?
even that, no. It's about 0.8, I think.
0.8 mil.
Yeah. But everything in there is stainless steel. We don't use aluminium plates or anything like that. And these, if you notice on the back here, the plates have got their own ident labels as well. Now this one, on the hot water one, this is the new plus type plate on there. You can see it there. I'll show you what the differences are. Just see there. Got it?
Yeah.
And I'll just show you what the differences are. If I just get to my bag.
Normally a private school or something.
Have it. You know, normally a heating hex plate is herringbone pattern.
Yeah.
That's the normal plates, is a herringbone. The plus type plates are now like that. So that's got more surface area,
Point there.
so they can make the plate smaller for a bigger output.
Bigger output, yeah.
However, you imagine if you look at the waterways through there,
It's gonna, yeah.
it's slightly easier to block. We've had that on the heating side, not really on the hot water, we've had it on the heating side. And what we found is where the guys have done the flushing and initial cleaning, putting cleaning chemical in, they've then not emptied it properly and flushed it, and they've left some of the cleaning chemical in. They then added an inhibitor, and the inhibitor is reacted with the cleaning chemical, and it furs everything up. It took us ages to work out what was going on. It happened at the site, the old Peel Centre, the old Met Police Training Centre, where they're redoing lots of sites, lots of buildings over there. And we couldn't work out why they were getting block plates until it was sent away to Fernox for investigation. And it was the two chemicals that reacted together. They actually happened to be 2 different manufacturers of chemical as well, which is what they managed to buy at a certain time. So, but that's why we now do these plus plates. There's more surface area on there than that, because what they found when they were doing tests and they were doing ultrasonic scans, they found that the water would just run down the middle of there. But if they do it that way, there's a much more surface area and the water had
Surface
so it's like a cheese grater.
Yeah.
It's like a cheese grater effect without the holes in it. But it's about 20% more effective than the herringbone plate. So all Danfoss, but if it says plus on that label there, you know it's that type of plate. Not all of them will be like that yet, because we haven't finished changing them all. They've not all been changed over yet. But Danfoss don't buy those plates in either. They make them themselves. That's why I'm not allowed to have a big cut-up version of one of them. I don't want it to be seen. for competitors. They don't use anyone else's brought-in components. Everything is Danfoss on these, on there. We carry spares for everything, but as I say, if you ask for plates and bits and pieces, you will get 50 questions from Kevin and Kelvin as to why you need something.
When it comes to that, they'll investigate everything
Yeah.
if it's been
Yeah.
patched correctly.
I mean, it doesn't always happen though. We just get phone calls from people saying, "Oh, your plate's blocked. I need a new one. Have you done this? Have you done that?" And we know full well people just say yes for the sake of it. We go to site and it's not that. I've had units.
Always
stripped
you
down
guys will
from-
prove us wrong anyway.
Yeah. I've had it where I've been to site. They're saying, you know, it's a block plate, and I've been there and I've taken the thing apart and it's a block dirt strainer. But they insisted they cleaned it. Now, you know full well they have because you caught them out, but it does happen over the phone on there. Everything is user serviceable. They're all, sorry, you're serviceable, not user serviceable. All flat face unions. I can send you some special spanners in case you need some. I'll send you a couple of sets and some spare washers if you need them as well, just in case. If you ever need some spares like that, I'll get that sorted out for you on there. But everything is a flat face union. The only different one, slightly different side, is the pump union, which is an inch on there instead. Everything on the heating circuit side is the same as the other units. Setting procedure is exactly the same. It's just setting that hot water temperature control valve is different to that one on there. But if you use my setting guide as a way, they're pretty accurate as to where it is on there. Again, if you can't produce hot water, check that someone's not got the bypass open somewhere. Doesn't have to be that bypass, it could be another one somewhere. Or is it the dirt strainer, or is it a primary systems issue? So you can use the energy meter to diagnose issues before you've actually taken the unit apart. Have a look and see what's going on there and what's happening. Once you've set it, again, there's nothing really for the apartment owner that would need to touch on there. But we do get other plumbers, you know, after your defects period, they could call anyone in. And the amount of grief we get, they just turn everything up to fix it. Because they don't always know what they're doing, unfortunately. But they're relatively simple, once you get used to them. It's not rocket science, otherwise they wouldn't let me do it. But yeah, they are relatively simple. It's just following those procedures. It's nice to see, is it Soren? Sorry, what he's doing, because he's doing it properly. And it's being done properly, which is rare. It's getting better. That's why we do this training, to make sure people are aware. But as I say, you could just hang this unit on the wall, give it some primary system, and it will work. But it won't work to how well it should be working, and as it won't be working as efficiently as you need it to for the boilers to work as well.
So in order to set up that valve, for example, we can see it in the spec for the I guess, or not?
Yeah, the way Danfoss say it, they do it the other way around. They start from fully open and wind it back. It's much quicker, and I find it more accurate to do the way I've done it. We look at that primary temperature now, because we haven't run anything for a while. If I go to loop 2, still no flow, it's still dead, still nothing.
48. Like you said, 8 below the
It's
55.
about 8 below the 55 degrees.
It works perfect.
It will vary, but that's pretty good. It's not exactly 8 degrees, it's going to be, you know,
Just around there.
degrees, but it's around there. So it's still dropping on my return temp. It's still 23, so my return temp is still coming up. It will take longer, slightly longer.
So, all this information
It's
is
all on there.
all in here, yeah? Whatever
Loads of
you've
it on
just
there.
given
Yeah,
is in
everything's on there, yeah. I've got a whole printed copy for you as well, and bits and pieces. So, that's been set pretty well on there.
And then the heating, what you said, just above of there.
Yeah, the
Just
pump
that
is
balance
exactly the
Rough feed
same.
there, yeah?
RAVK exactly the same. Again, it's based on closing temperatures. People forget that one. So it's slightly over. So if you want to maintain 42 degrees, you wouldn't set it to 42 degrees. You set it slightly over. That's where that app that I use with those 2 Testo clamps comes in really handy don't expect everyone
It's
to
good
buy
evidence,
them.
that.
But it's good evidence, especially because you can do it as an Excel spreadsheet. You can clip that for every apartment to your check-in sheet and say, that's what we got over a period of time. It's quite handy, and also they do it, it's got apps for measuring flow rates and
Especially
leaks
with
and
underfloor
stuff.
heating, that you cannot show
Yeah.
what she was saying, that it's gonna take longer to.
Yeah, trying to prove
get-
underfloor
yeah.
heating's working is an absolute
It's
nightmare.
more easy, you can actually prove that
Yeah.
there's heating
Yeah.
going through at least.
Yeah, but as long as we can only control the return, give you the return temperature if the underfloor is balanced properly.
Yeah, that's true.
And as we know, trying to set, I mean, the weather's changing now, but if you were trying to set the underfloor heating in the summer, you'd be fighting a losing battle. Because the apartment's going to be above your temperature trying to come out
Temperature,
anyway,
exactly.
and we've had this before, trying to, even with radiator circuits, where they want, they're now asking for 20 or 30 degree delta T across the radiator circuit. If you're trying to do it in the summer, you can't do it because you just got nowhere for the room to extract the heat.
You just have to leave the FCU
Yeah,
on
and
for
I've had,
fucking all
yeah,
day.
I've had stand-up rows with people on site because they won't accept, well, I need to get the heating circuit working, and it's like with underfloor, but the room's already 30 degrees, how am I supposed to get the heating to come on? But they don't always get it,
Yeah,
unfortunately. All right,
Alright,
are you happy with everything? Yeah?